guys, today we're going to do 5.3, solving polynomial equations. The objectives: to solve polynomial equations by factoring and to solve polynomial equations by graphing. If x minus a is a factor of a polynomial, then the polynomial has value 0 when x is equal to a. If a is a real number, then the graph of the polynomial has a, 0 as an x-intercept. In order to solve a polynomial equation by factoring, we are going to write the equation in the form of a polynomial is equal to 0. So 1 make equal to 0. 2. Factor p of x. Use the zero product property to find the roots. 2. Factor. We are going to review a few different options of factoring. 3. Set each factor. Equal to 0. Solve x. When we set each factor equal to 0 and solve for x, that is us using our zero product property. Number 1, solving polynomial equations using factors. What are the real or imaginary solutions of each polynomial equation? I'm going to subtract 3x from both sides, and I get 2x cubed minus 5x squared minus 3x equals 0. I have a GCF of x. I now, inside my polynomial, have 2 times negative 3, which is negative 6. What multiplies to negative 6 and adds to negative 5? 1 and negative 6. I need to check. 2x minus 6. And I need to check 2x plus 1. I can divide here by 2. So my factored form, it would be x times x minus 3 times 2x plus 1 equals 0. Now set each factor equal to 0. So x equals 0, x minus 3 equals 0, which means x equals 3, and 2x plus 1 equals 0. Subtract 1. 2x equals negative 1, divide by 2. X equals negative 1/2. Those would be my 3 solutions. Do the same thing here for problem B. I made my equation equal to 0. I now take out my GCF of 3x squared. I get x squared minus 2x plus 4 equals 0. We are now going to check if we can factor. What multiplies to 4 and adds to negative 2? That does not work. Since it does not work, we have to set each factor equal to 0 and solve. Since we can't factor this, we are going to have to use the quadratic formula. So 3x squared equals 0. I would divide by 3. X squared equals 0, square root. X equals 0 is one solution. Now I'm going to get imaginary solutions for my quadratic. I have a is 1, b is negative 2, c is 4, so the opposite of b is 2 plus or minus the square root of negative 2 squared minus 4 times a times c, which is 4, all over 2 times 1. 4 minus 4 times 4 is 4 minus 16. Over 2, which is equal to 2 plus or minus the square root of 12, negative square root of 12, over 2. We can simplify 12 into 4 and 3, we're going to take out an I to get rid of the negative. So I can take the square root of 4, not the square root of 3, 2 plus or minus 2I root 3 over 2, and we can now divide by 2 in both terms, so 1 plus or minus I root 3 would be our other two solutions. Here is a review of factoring techniques. One, we have to factor out our GCF. Trinomials is when we use our triangle. Perfect square trinomials, difference of squares, factoring by grouping, we will get to in a second. Sum or difference of cubes is new to us as well. We are going to factor. Going to get 0 by its on one side, so I have x to the 4th minus 3x squared minus 4 equals 0. I can still triangle here. I get what multiplies to negative 4 and adds to negative 3, which is negative 4 and 1. Now when I'm making my factors, I'm not going to write x, I'm going to write x squared because we want it to be equal to x to the 4th. So x squared minus 4 times x squared plus 1 equals 0. I can continue factoring, and I would get x minus 2 times x plus 2 times x squared plus 1 equals 0. Now I set each factor equal to 0 and solve. X minus 2 equals 0, so x equals 2. X plus 2 equals 0, so x equals negative 2. X squared plus 1 equals 0, subtract 1. X squared is equal to negative 1 square root. X is equal to plus or minus I would be my 4 solutions. I still, when I have a cube, need to get it equal to 0, so I have x cubed minus 1 equals 0. This is a difference of cubes, so I will be following this formula. The cube root of x cubed is x. The cube root of negative 1 is negative 1. So it's going to be x minus 1 is equal to, I'm lying to, times x squared plus x times 1, which is x, plus negative 1 squared, which is 1, is my factored form, equals 0. I set each factor equal to 0. So x equals 1. I do not have two numbers that multiply to 1 and add to 1. Therefore, I need to use quadratic formula again. The quadratic formula is the opposite of b, so negative 1 plus or minus the square root of 1 squared, which is 1 minus 4 times 1 times 1 all over 2 times 1. Negative 1 plus or minus the square root of 1 minus 4 is negative 3 over 2. This is equal to, we're going to make this positive and an I, negative 1 plus or minus I root 3 over 2. Once again, set it equal to 0. Subtract 12. 3x cubed plus 12x squared minus 3x minus 12 equals 0. When we have 4 terms and we do not have a GCF, we are going to group. So I'm going to group by taking the first two terms and the second two terms. Out of the first two terms, I can take out a 3x squared. And I would then be left with x plus 4. Now when I take out the GCF of my next two terms, I need to, inside the parentheses, to be x plus 4. So I'm going to take out a negative 3. When I take out a negative 3, I would be left with x plus 4. Now I can rewrite this as x plus 4 times 3x squared minus 3 equals 0. I just factored by grouping, and now I can take my factors and set them equal to 0. So x plus 4 equals 0. 3x squared minus 3 equals 0. I'm solving for x. X is equal to the square root of 1, which is plus or minus 1. Subtract 4. And x is equal to negative 4. When we are solving by graphing, we could either set both sides of the equal sign, put them in y equals, and find the intersection in trace, or we could move everything to one side, make it equal to 0, and then use the 0 function and find the zeros of our polynomial function in second trace. That's all.